All right, this is the homework help for 3.1 and 3.4, which is really one section on applications of linear equations. And so we're just going to do a handful here. Let's look at number 23 from the homework. 3 times the sum of a number in 9 is 12. So 3 times the sum of a number in 9. So when I see the sum of a number in 9, I know this is going to be in parentheses, right? So 3 times the sum of a number, that's what we don't know. Some number, we're going to let that be x and 9. So the sum of number 9 times 3 is, which is always equals 12. That is usually the hardest part of these, is setting up the equation. So to help that, you've got a couple options. Since 12 is easily divisible by 3, we could divide both sides by 3. That doesn't always happen. So we'll just go ahead and do the standard way, which is to distribute that 3 onto both terms. So we'll get 3x plus 27 equals 12. We'll go ahead and subtract 27 from both sides. Those cancel, and I'll get 3x equals negative 15. And the last step here, almost out of room, divide both sides by 3. And I'll get x equals a negative 5. And we can always check this. So what is the sum of a number, sum of negative 5? So the sum of negative 5 and 9 is negative 9 plus 5, and that's 4. And if I do 3 times that, what do I get? I get 12. So that checks out. So we can often check these. Okay, here's my check. Okay, let's see, 33 is pretty close to that one. Let's look at this one here. The sum of 2 consecutive integers is 77. So, and then find the integers. So the first integer, we don't know what that is. We'll just say it's x. So what would the next one be? The next one would be x plus 1. And if I'm going to sum them, I'm going to say x plus 1. Now we could put that in parentheses, but they don't really buy us anything, so I'll just leave it out. Equals 77. And so then I do the math. 1x plus 1x is 2x. So 2x plus 1 is 77. We'll subtract 1 from both sides. 2x equals 76. And then divide both sides by a 2. And I'll get x equals, what is that, 38? Now, let me take an add-on here. What if it said the sum of 2 consecutive even integers? So if I said even integers, what would that be? Well, if the first one's x, what would the next one be? Well, it's not x plus 1 because that's the next integer. So like if my integer, let's say my first integer were 6. What's the next integer? Well, it's 2 more than that. Whatever number I pick, the next one is going to be 2 more. So my next one is going to be x plus 2. And I put that in parentheses just to emphasize it, equals whatever we say it's equal to. And the same thing would go if it were odd, because we're skipping a number in there. Okay? So just sort of if you see even integers, odd integers, make sure it's not always x and x plus 1. It is if it's 2 consecutive integers, but if they put some sort of stipulation on it, make sure you take that into account when formulating your equation. Okay, we just have 3 over in the back. I'm not going to do 211. Let's look at 215. So the perimeter of a triangular pool is 36 yards. The length of the 2 sides are 10 yards and 15 yards. How long is the third side? So I almost always will draw a picture on these. It does not have to be to scale at all. Just draw something so you can have some labels on it. So there's my triangle. The lengths are 10 and 15. So we'll just call this one 15, this one 10. It's sometimes helpful if you've got one side bigger than the other that actually you've written it bigger. Doesn't have to be. It'll just make the answer make a little more sense in the end. And we know the total is 36. So there's my unknown. We call that x if you want. You can call it any letter. And so my expression or equation would be 10 plus 15 plus x equals 36. And the moment I'm leaving the units out, and I just need to make sure I add those back in at the end. So we can combine my like terms. I will subtract 25 from both sides. So 11 yards. Make sure you include units on these when they're appropriate. Now, do we really have to go through all? It sort of depends on what the teacher or I require you to do on these. Sometimes the answer is write an expression or equation that represents the situation. So in that case, you would. This one was not that hard. We probably could have just added those up in our brain, 25, then subtract it from 36. But it is nice to get used to showing work on problems that are relatively easy so that when they get harder, like in 233, that we already know how to represent unknowns and how to tie this together in an equation. So let's look at 233. The angles in a triangle are such that one angle is twice the smallest angle. The third angle is 3 times as large as the smallest angle. Find the measures of all 3 angles. Okay, so again, don't stress about drawing your triangle. I'm just going to try to draw one angle fairly large and a couple of them kind of small. Okay, here's my smallest angle that I've done. We'll call that, it's unknown, it's X. You can call it anything. So we'll call that angle 1. Now what about angle 2? So one angle here is twice the smallest angle. So if that's angle 2, what's that going to be? Good. 2x has nothing to do with that 2 right there. Just I'm labeling it second angle. Now what about this angle here? This third angle, again, it happens to be 3 times as large. So 3x. And recall what the sum of the measures of the angles of any triangle are. It's 180 degrees. So 180 degrees is what I'm going to sum these two. So you want to write that expression. You can say x plus 2x plus 3x equals 180. And then you'll solve it. So 1x plus 2x is 3x. 3x plus 3x is 6x. So we have 6x equals 180. Divide both sides by 6. And I'll get x equals to 30. Now here's where you have to be careful on these application problems. It says find the measures of all 3 angles. Often students will just end right here. Or the question is even, in some ways, can be trickier. It says what's the measure of the third angle or the largest angle? So we would need to take that 30 and find it out. So angle 1, here's my symbol for angle. So angle 1 is 30 degrees. Angle 2 is twice that, so 60. And angle 3 is 3 times the smallest angle, which would be 90. All right, so I hope that helps.